put in a marker for starting, and something yesterday that I sort of like forgot to do it. Like I started working on the grid, but then I realized that we could actually, after each of these sort of like features that we add in, come into the Raspberry Pi and see how things are working. That way, as we build along, if we do something that's going to cause a slow reaction on the Raspberry Pi, we're going to find out right away. So I pulled in the changes right before the stream and I started building for release mode. It compiled, it looks like. So let's cargo run. And so we see it, we see that sort of fall there. And I'm really curious what we have set up for this in the API source. I think it's the config mod. And we can see our target update FPS is 50. So that's what we're going for here. And here this is again as it falls down. I mean, it's decently smooth as it updates. There is a little tiny bit of hitching that I noticed, and that I'm never really quite sure exactly what's causing that, because I'm not like I'm doing one draw per frame. There's nothing really else going on. Now it is right after the Pi has been boot, like the not the Pi has been booted, but the app has been booted, and I know that sometimes it works better when I wait for a little bit and then I hit go, so I have like a trigger that causes it to go off, or like a starting soon screen. That might be something that would be good to implement sooner than later so we can start testing. For right now, though, I do want to get a grid showing. And I'm going to go ahead and minimize that. I'm VNC'd in, and that's how I can see it. All right, so what was today's plan? I think we were planning on making, like, visualizing a grid, although I'm not completely, like, we may have to refactor this later. I was thinking last night that the camera is going to like have to shift the grid over, so I'm going to do this based upon the world coordinates, and the world is going to be bigger than the screen. At least it potentially could be bigger than the screen. So where are we here? What am I doing? I need to open up U and open up VS Code. So let's see, who is doing this? This is the world, I believe. We have our width and our height. And the other thing that we were adding in is we have this world unit width and world unit height. And that's going to be controlling the size of each of the squares and units. And I'm doing this because I eventually want to create, be able to say like, oh, a floor is like this unit. And this is going to be used, I think this is going to be used quite often for like a variety of sizing type things. And it's possible that it won't be used. But I have seen like quite a few other game developers use this behind the scenes. So I want to, I'm hoping that if I use this, it will help me out. Now, of course, if it doesn't, then I'll learn that it's not as helpful as I was hoping it would be. All right, so what are we doing? We are showing off the grid, which means that we need to take this world unit width and world unit height and add that into the world too. So let's create a test for this. Okay, so test CI, this is gonna be set world unit size. So that means world default. Okay, so that gives us a world. And then we're going to assert equal what like the default world unit width and height is. So assert equal world dot unit width is going to be, let's just say it's like 100.0 to begin with. Or maybe even we're 1.0. That's what it starts with. It starts with 1 pixel size. And you're both equal to that. Okay, so we have to set that ourselves up for us. So width 32, height 32, and then when we create our default here, we want to now set these. So unit width. I'm going to set this to 1.0. Height is equal to 1.0, and then we're going to store these down here. And you need, what are you upset about? Oh, strict comparison. All right, so this should be happy. It should pass this test because it's able to see that, you know, we have a world width and world, like unit width and unit height. The next thing we want to do is make it so that we can now change these and set it. So let's say world, it's going to be equal to world dot set unit size, and we're going to pass in something like 50.0, 75.0. So this is going to allow us to set it to non-squares, but in this case, like, and that's in this case, I'm doing that for testing purposes. I'm probably going to start with squares, and then we can change it around if things make sense for us. All right, so yeah, this we're going to toggle bit rating with a party of 136. Welcome Togglebit and Raiders. Hello. Emil hello. Panev. Togglebit, obviously. Togglebit, how was your stream? What were you working on today? Hello, Stacking. And Sure Shock. Work stealing? What does that even mean? Oh, you stole Sure Shock's job? Wait, how does that work? How does that work? All right. Well, since we just got rated and we now have 178 of us here, one thread produces values, and then we have a bunch of other threads, and one of them steals the value. Oh, interesting. And I assume this is in Rust, right? So, I hadn't thought of like how that could work. That could be that could be really interesting. Always Rust. All right. So when we get rated, we often play the Get the Streamer game. It's a game that we've made here. You have to run, but have a great stream, Brickcirc. And thanks everyone. Well, thank you so much again for the raid toggle bit. You have a good meal and rest of your day. And I'll probably see you online in some of the other streams. All right, so we're gonna play the Get the Streamer game. It is a game that we made here live on stream. It's going, basically, you all in chat are gonna have commands that you run, like #fire, #sword, #snake, with the column of where you want to drop it down. I'm gonna be the character at the bottom, trying to avoid them all for as long as I can. See Sure Shock with attempting to go a little bit early. It doesn't allow you to do that. And we'll see how long I can avoid with all of you in chat. And the scoring system that I have here is it's 1 point for dropping, no matter what you drop, heart or a weapon or a snake, and it's 10 points if I get hit, and that's true even with the heart. So you can get points for helping me out. In the case you don't want to attack me. Oh, I got. Okay, I got the heart at least. Ah, 2 hearts. I mean, I'm getting hit a lot, but at least I'm also collecting these hearts. At least I shouldn't run into the fire, probably. Oh, come on. There's too many! Oh, okay. That was the most crazy that we've had this game so far, but that was a lot of fun too. Looks like Nipsey with 42. Oh, Sure Shock with 72 points. That was pure chaos. Oh yeah, it was. That was great. That was a great one. Overkill, yeah, but that's still good. See, this game is amazing. Thank you so much. This was a lot of fun when we made it live on stream, and I think it's a lot of fun to like play it here, especially when we get rated, because people can come in. We can just sort of like, it's a good reset for like right when we're about to get back into it again. And my tea has finished brewing, so before it becomes too strong. All right, so what we are doing right now is I'm building it's not really a game engine because I'm using GGEZ as the game engine. It's more of like a template that I can use to build platforming games. I am trying to use good game programming patterns for this. I'm using this book called Game Programming Patterns in order to sort of keep myself in line with what I want to go. This is the book. If you want to read it, you can purchase it on Amazon. The author has a link. But if you want to just sort of check it out, there is a section on the web where you can just read now. So we did read through the entire book online, but I didn't actually like fully implement everything into an actual like full game. I think we just did like one example type thing that we tried to put a bunch of things into. So right now, when I can't run this yet because we've got this set up. So let's finish updating this. We're gonna have the ability to set a unit size, like a standard world unit size, and then I want this to be a certain equal world dot unit width is now going to be 50.0 assert equal world dot height is going to be 75.0 after this runs. Now I haven't written this yet, so obviously we need to do that. So I'm using the builder pattern for this. So set unit size, it's going to go into here. And take immutable self, a width, which is an F32, and a height, which is an F32, and we're going to turn a self. Okay, so self dot. This is going to be the unit width is equal to width. Self dot unit height is equal to height, and then return self. And that should make that work. If I run this test. All right, we're all good. Everything is working there properly. So, and that means I can now run what we have right now, which is not the most impressive yet. What we have is a game entity which is essentially a player, and it has gravity applied to it, and so it falls. What's and Yeah, it's not that really interesting right now. What I want to do is want to draw a grid out according to the standard world unit sizes, and the world is going to be bigger than the camera size. The camera is going to be whatever this window is, and I'm going to want to draw the grid according to what the world is. Uh, we're not going to draw the grid very normally all the time. It's going to be for like development purposes to make it really easy for us to sort of see. Don't knock gravity. It's very important. We wouldn't be here without it. Of course. Of course. We have to have a good gravity. I'm also controlling a lot of this information through a configuration file. So right now I only have a config with a default on it. I'm going to be grabbing this information from a JSON file at the end, and then probably building some kind of design like program. It might be with a WebAssembly and JavaScript, just sort of like a web form that we can then create the world, set all of these things in that we want to, hit save. It'll save to this file, which then we can run the application. And then that way we can iterate on like making the game look really good without having to constantly recompile over and over and over again, which will be nice. But until then, we're just still building out the features. So the recompiling is going to happen regardless. All right, so we want to now store this world unit width and height. And that's going to happen in the main library in new. Here we have the world. Where is that? World set size. I'm going to add in set unit size config dot world unit width config dot world unit height. And okay, so that should give us now whatever we want this to be. And I think that we've already set this. Come on, go there. We've set this to be 10 pixels by 10 pixels. Okay, that makes sense. And then we want the world width and world height to be 5,000 by 5,000. And so this also makes sense for us. We're going to be able to 10 and 5,000 divide evenly into each other. So we should have 500 squares width, like wide and down. So that should, and then that's of the entire width. We have a lot less than that. That's going to be available to, like, visible to us on the camera. Did I finish the Pitfall game? No. So I ended up sort of kind of coding myself into a corner, not really super happy with it. And that's why I decided to pivot back to this one. Plus, there was no way I was going to get done with that by Christmas time in order to ship a Raspberry Pi to my father to give him the game on it. So I decided, you know what? It's going to be his next gift giving opportunity. Could be that. And that that's going to give me some time. I'm going to therefore up my skills on game dev in the meantime, so that way I can then do this. Also, I have a big project, like a personal project that we'll see how much I can do on stream. I'm not sure. That's coming up in January, and that's going to make it so that I can't really like provide patches or any other support for that game. So I wouldn't want to like give him a half-finished game and then I don't know, like try to finish it and like remote update it. I'm not even sure. Like it would be a really close call. So I didn't want to do that, and I didn't want to crunch for like personal stuff. That feels like it's not really helpful. All right, so if I want the world to now draw a grid. So here's our draw function. Now we can just create all of the grid items as like a mesh here. I could also create a grid mesh here as well, and then we can potentially just not draw it, or we could even just like remove it when we don't care about it. So we can have our grid is going to be a mesh. Now that being said, I probably don't need to actually store it in here, do I? I can store this in the drawables. So we have this player mesh. Let's do a pub grid. It's a mesh. So when we have this player that we create here, we also want to create this for our well, I guess it's just for the world. Now, what is a grid? It's just a bunch of lines going down and a lines going across that represent, well, that grid. Like each unit size is going to be the square, and that's so I can visualize what the unit sizes should be. How fast they're falling. Like it is things looking good, like jumping wise. So if I create this, I need to figure out how many across to make. I'm actually thinking that I might want to have some functions that we add in here. And also, we're going to have to take in the config. Now, is that true? Do we need to take in the config? I mean, library, we're creating, here's the drawables. We're creating the world before the drawables, so might need to do this. Oh, you know what I can do? We can create the world like this. I could pass a reference to the world, which would give me the world. I would then be able to get out information like what the unit size is. Either that, or I could add this, like add that in here. Sirius 0002. Hello. I think I got the right number of zeros in there. Okay. Let's pass in a reference to the world. Let's do that for right now. You're more cheery than the other coding streamers that you've met already. I tried to be. Like I try to I don't know, being really negative to me, or like just being really serious, like that doesn't seem fun to me. Although there's been times when I've been very low energy on stream too. It happens. I found a new tea that gives me like a lot of caffeine, so that helps a lot. So you'll see me drinking that until I run out. Then I get tired again. All right, so we're gonna have the world, which is gonna be a reference to a world, and we're gonna want to create that. I'm thinking that creating a function for this function, create grid. Now I can't really create self here for this because the grid needs to go in self. So I think what we're gonna do is we're just gonna take in world, which is a reference to world. We need to create that context too. We're gonna return a game result with a mesh inside. And all right, let's just throw a to-do in here right now so it doesn't yell at me. Get seriously tiring after some time when a basic question by joining a new stream gets you a 10-minute timeout. What? The Recently, the only timeouts that have been given out is by Nightbot because people post links to places that I hadn't predicted links were going to be posted to that also are okay. Uh, and then Nightbot is fairly heavy with the ban hammer on that. But usually it's okay. We do have a cute kitty, which I don't think is around right now. He got upset at me because he didn't eat all of his food last night. So I put it into the refrigerator. I took it out this morning and he was seriously unhappy that it was cold. He did not want cold food. So he just meowed at me all morning. And I don't think he followed me. He didn't follow me down here. So, at least I don't think he did. Yeah, I have a heater behind the green screen, and he's not hanging out by that. So, he's probably upstairs with my wife trying to ask her for warm food. All right. Enough procrastinating. I'm procrastinating creating this grid because I have to do math. Even though it's like basic math. So, the idea is that I want like grid line, grid line, grid line, grid line. We can just do something like really basic to begin with. So I want to first calculate how much space between each of the lines is going to be, because we're going to start with a single line. And I guess like if we yeah, we're going to need a for loop this too, aren't we? We're going to have to do something like for loop for the number of them that go across. So we have to calculate the number of them that we have, which is going to be okay, so we're going to do the width first. And that means we have to start the builder pattern first. Okay, so we're going to start let mute grid equals, it's going to be a mesh builder new. Now, I'm going to have to loop inside of this and reset the grid so that way we constantly get what we're sort of going for here. Okay, so then I need to do let the number of, so this is going to be the horizontal tile spelling. That's why I have a spell check in here. It will yell at me. Oh. Horizontal. Unknown word. Will you help me there? Oh no, all you do is tell me that it's an unknown word. You don't help me spell it. Okay, it's not telling me it's an unknown word anymore. That's the correct spelling. Okay, so let horizontal count equals, and this is, we're going to take the size, so that's going to be the world dot we need these to be public, so a unit width and unit height needs to be public so that I could get access to these. Okay, so unit width divided by, and this is also going to be the full width and the height here too. Okay, so world unit width divided by the world dot width. That should give me a horizontal count here, and I'm wondering if I should make this like not an F32. I don't remember what happens if I iterate using floating point numbers versus like, you know, integers. So if we do a for that count in 0 ... horizontal count. So just out of curiosity, what is our count? What do you look like? Wrong language for that. Okay, so mismatch types. Okay, expected integer found at F32. So this needs to be an integer. I could convert this. So an as a usize. And then we're going to debug count, and I need to reference that so it doesn't take ownership. Oh no, you're a macro. Still need references so I don't take ownership. Although count is a usize, it's going to copy it. Like if I do this, it'll just implement copy behind the scenes and then just take ownership and print that out. To do will yell at me, but at least we'll get the count printed out first. So I want to cargo run this. Actually, no, we know what this is. This is going to be integer. It's going to be correct. We're going to be fine. I don't need to check that. Okay, so we have a count for this, and we're going to multiply this to figure out where we're going to start the next grid item. And so that means we are going to start at 0x, and let's say we are doing a horizontal, so that means we're going down and doing the horizontal lines. I did width, so this is actually vertical count. Okay, so for vertical count, I want to, for the x is always going to be, well, the x is going to be the one increasing, the y is always going to be 0, and we want to create a whole bunch of lines. So I want to say grid is going to be equal to grid.line. And then we have to create the points. And so there's only 2 points that I really care about here. So let's actually create that here. Now, points, what kind of points do you need? Mint points. That's what we need. Mint points. Okay, so points is going to be an array of where we're starting and where we're ending. And so that's how it knows where the line goes. So we want a 0.2. And we have a mint 0.2 right now, so that's fine. And x for that is going to be, so we start at 0. But then the next one is going to be our, whatever the world size is, the standard unit size times this count. So that's going to be world dot unit width times count. The problem is this count has to be an as F32. So a little bit of conversion there. Not the best, but hopefully it should be close enough for us. And then the y is always going to be 0 to begin with. Then we're going to do another point for the ending. The x is going to be the exact same. So that, maybe we can just do this as let x equal to u. Then y changes, right? So we're gonna have a let start y equals to 0.0. Let end y equals to, and this is going to be, now I'm going to build this as not displaying on the full screen. It's just going to be the full world display there. It's not really the best performance wise, because I really should only be displaying what's on the screen, like what's in the camera. But our world is bigger than their screen right now, and that's fine. It's going to world dot Not unit height, but height. So we're going to start with start y, near y. That. Okay, then we're going to have x, y is end y. And so then points becomes a reference to these points. Okay, the width. How wide is where one of these lines going to be? Let's try just a 1.0 for this. And then a color. Let's try just pure white and see what that looks like. Okay, so then if I do this grid, what are you upset about? Oh, you return a result, so question mark U. Expected mesh builder found mutable reference to mesh builder. Oh, I know what I can do. We want a mutable reference here. And so I'm getting mutable reference back here. And there we go. Okay, so at the very end of this, we want to build it and return it. So we're going to return a grid.build, pass it in that context. This returns a game result with the mesh inside, so I don't need to do anything else. I don't need to wrap it in OK or anything like that. Penzizi, you redeemed Pet the Cat, but I don't think Kitty Cat is here. Cat Cam is showing an empty, sort of like the tree that I have right next to the desk. Let me check right behind here, see, right behind the green screen. Let me see if he's down here in a basement with me. If he is, I'll bring him over and we'll do a little bit of Pet the Cat. Unfortunately, he's not here. I'm sorry about that. I'll keep that reward up just in case, as a reminder. In case he does show up, we'll do a Pet the Cat immediately. All right. So if I do that, Kitty is angry. I know, Kitty's angry at me. I forgot to we have that super freeze-dried food for him because it's like the highest quality food that we can find, and there's also a local store. We ran out of canned food, and so we bought that from them, and I have to remember to soak it the night before, otherwise it's practically it's really bad for them to eat it because it'll just soak up all the water in little Kitty's body, and that's I don't want to do that to him. But all he wants to do is eat the freeze-dried without it being soaked. Kitty will decide when to pet him, not us. Yeah, unfortunately, that's true. I have some ideas of what we can do to attract the kitty more often, though. Maybe in the new year, we'll do some of those things. We can build some things that will maybe play with the kitty. All right, so let's now create. We're gonna do let grid is equal to. This is gonna be self with a capital S because this is more like a static function if we're coming from an OO world. Create grid. We're going to pass it in the reference to the world, which we already have as a reference to the world, and the context. Question mark this, semicolon, and we have the grid here. And so that makes you happy. We only have the lines going across, and I'm okay with that right now. I want to see whether or not these actually work. So in the world here, in draw, we have these drawables, I draw the entities. Before we draw the entities, so the grid is below it, we're gonna draw this. So we're gonna do draw context. The drawable is gonna be reference to the drawables. Oh, come on. There you are. Drawables dot grid. And then params, I'm not gonna change it or like translate it at all. So we're gonna do drop param new and leave that as default. Oh, I do have to question mark that. So if I run this, we should see line. Oh, it didn't like that at all. Trying to build mesh with less than 3 vertices. This is usually due to invalid input to a mesh or a mesh builder. Okay, so this is where it failed. So what happened? Now when we create a line here, this doesn't really say anything like, This doesn't really yell at me for like any good reason. Because I can't see, this should be giving us plenty of these. Okay. Let me try just manually creating this. Like, so instead of the for loop, let's do one of these. So if I start with X as this, and then we'll, so that's going across. So if we imagine that this is going to be plus, standard unit size is 10. So if we do, like, our count is going to be, let's say it's the 10th one. That's kind of like what it's going to look like inside of here. Yes, I know you don't have to be that way, but I want it to be as close to this as possible. We have start Y and Y. Actually, you know what I can do? I can do this. There. And Y points. Okay, so if I just do one of these. How about that? Are you going to crash on me at runtime? Okay, so here's our line for one of these points, and this is 10 across. I think I made my lines a little bit too small. But anyways, that's neither here nor there. So what is this? What do we want to do then? We want to have a second one of these. We go through this loop again. Let's say this gets shadowed. Count is now 11. X is this, start Y is still this, and Y is still this. Points is still this, and then we add the grid in here. Okay, so we do this twice now. Okay. So that's working. Now, what are you? Debug our vertical count. Well, that's a problem. Our vertical count is 0.002. So okay, so what is our unit width and world width are, that math is not what I expected it to be. And I think that's the reason why it's not going through that loop. So it's trying to create the mesh with no lines in it. The division is reversed. Did I reverse the division? Ah, stop, go back. Back to you. Unit width divided by world width. Because what I was hoping to do is that, where is this? Where's my world? World, you're right here. Our unit width would be something like this, where it's like 1. And then the world width is like the bigger one. The width divided by unit width? Okay, let's try it. So we'll do width and unit width. So if I do that, come back to here, we reset you. You don't need this count. Save you. All right. There we go. You're exactly right. Thank you so much, Smiley, for that help. So here's our lovely grid. It looks wonderful, doesn't it? So first of all, that white is just a little bit too strong. Let's actually create this as a better color for us. We're gonna do a color, new. Now I'm okay with making it white. So that's what 1.0, 1.0, 1.0. But then let's make it something like 0.5 alpha. I'll do a color like this. And that should make it a little bit less glaring. The other thing I want to do is I want to come back into the world and change in our library, change what our unit size is. Oh, this is for the config. So we have these being 10. What if I do something like I have it 100 by 100? I mean, not terrible. Maybe 50 by 50 would look better. Okay, I think that looks good. Now we notice that doesn't look even according to this window, but that's because this grid continues on way off to the side here. Now, if I want to add in the horizontal lines as opposed to just these verticals, we're going to come into our drawables here. We need another loop here. Now, I can't guarantee that we're going to have the same size width, so I have to do this as a separate loop. I can't just do it as one. So we're going to do horizontal count is equal to, so this is going to be world dot height divided by world dot unit height. And we're going to do pretty much the exact same thing here. So for count in, this is going to be horizontal count as U size. That X equals, okay, so this is going to be world. The X now is going to start at 0 and end at the end. So X starts at 0.0. And you're going to be a start X. Y is always going to be sort of like the same. It's going to be set. So Y, you're going to be the what is that going to be? It's going to be the same thing that we have here, essentially. It's going to be world.unit height times count as F32. And let's do this as an end x equals world.width. Then we have our points. And then the rest of this should be the same. And then we also do, this is the same, where it adds in these grid points. So if I just do that and run this, I have 4 errors. Lovely. That's because, right, this needs to be start X, you're just Y, end X, and you're just Y. And I can't do that. I have to do the same thing we did before. X is that. X is that. So close, but not really what I was going for. All right, now no errors. And here we go. We have a grid displaying. Now this is the world grid, so when the camera moves, eventually when we have that, we're gonna be able to follow the ball and everything else will sort of work with that. Now, translating this, Chantilly, hello. Translating this is going to be interesting. Happy Friday. As the camera goes through, and I keep on forgetting exactly how to do this, I need to translate everything else sort of like up. So if the camera moves 1 pixel down, really, in this case, what's happening is that the grid is being moved up. So if I'm imagining moving down with this, and I don't have a camera here, and so maybe that's the next thing we need to do is actually create a camera so we can follow the ball. So how would that work for us? We need to display the grid is like shifting upwards. So the way this works is in our world, when we do our draw, right here where I have a param draw, I can then set an offset. An offset from the center for transform operations like scale, rotation, with 0, 0 meaning the origin and 0, 1 meaning the opposite corner of the origin. By default, these operations are done from the top left corner, so to rotate some... Wait, to rotate something... Right, okay, I don't think offset is what I want. We can do a dest. What else do we have in here? Maybe an offset is what I want. So I'm actually kind of curious. What would happen if I offset this by... Now this is like 0, 0. This is like a percentage that it gets offset by, it looks like. Because it's between 0 and 1. And that might be really hard for me to like fully calculate. What's this source? A portion of the drawable to clip as a fraction of the whole image. Defaults to the whole image. Oh, okay. So can I actually clip just the thing that I'm working on? And I can also scale it down too, so that we can see the entire world all in one go. That could be cool to like see the entire world. I want to try this offset though, and I want to store in. So I need a store in here. We're gonna do let's do like an offset as, what are you taking? You're taking an F32. So this is an F32. When we create this, I'm not planning on keeping this, so I'm just going to do this down here. You're going to be 0.0 to begin with. And when I do my draw, I want to then have an offset. Self.offset here. And then after we do this draw, I want to then say self.offset. Well, this is going to be a problem. Let's actually do this in the update. Plus equals to 0.01. So what are you upset? Okay, the trait bound 0.2. Okay, so offset is a mint 0.2. Okay, so we can just do self.offset, self.offset. It's just going to be even, so maybe it'll shift over in diagonals. Let's see what this does. Nothing as far as I can tell. Now, if I debug this, so I'm changing the offset. The offset is constantly changing. If I set you to be like 0.0 and 0 to offset, so the Y is the one being offsetted. That offset number should be growing, but I don't see anything changing sort of like at the corners here. I want to do a debug. Just to make sure I've done this correctly, like that we are running the updates. Yeah, so we can see it going up. It's going up way faster than we want it to, though, because it can't go up above 1. So let's actually decrease this by a couple numbers here. So I'm not sure if I can see what's happening. Like if I put my mouse here, so I'm not sure how I want to like draw my camera for this. My initial thought was I could have this grid on the world, and then the camera moves around in front of it. But I don't think that that's... This offset doesn't seem to be what I think that it is. So I don't think this is going to help us. Okay, so offset's no longer right. Yeah, we would have noticed it by now. Let's try the source. Let's try that instead. Okay, so this is going to be a, like, I'll just call it source. It's going to be a rect. Okay, so source is going to be a rect new. And we're going to name this, we're going to start with 0.0, 0.0, and then I want this to be the entire width of the screen. So for right now, I'm going to just manually hardcode set this to our resolution, which is 1280 by 720. So then we're not going to do an offset. Now we're going to do a source and have a self dot source. Now when we update this, I want to say self dot source dot. Now I want the width and height to stay the same. It's just going to be the X. We're going to increase by this. So we should see that increasing. And hopefully that should move us across XYs. See what this looks like. I put my mouse right here. This might be too slow because maybe it's not moving fast enough for us to see. But I don't think that this is doing anything either. Let's increase by more. Actually, this one, let's increase by 1. We need this to be much faster. Okay, and we're not. So I'm increasing by 1. We're already. I should see something by now if something was happening for this. I don't think it is. Have I reviewed how I did the infinite runner camera? No, I haven't. I should just go and do that. That's probably the best way to do it. All right. Let's go review our old code. Also, hello, Utsby. Emil Karu. So you're saying it was offsetting? Okay, I didn't keep any of that here. Let's go find it. Oh, this is the wrong one. I need to go to my... this one. Here we go. Not one of these. Where did I actually call it Infinite Runner, or was it something else? I feel like I didn't name it something important. So it was before jungle. It might have been in here. Here it is. Okay, our Rust GGZ Infinite Runner. Oh wait, you saw the grid moving, but it might not have been. I didn't see it running on my side. Up, Utsby, you found my code before I did. Let me this. Here we go. So we have an actual camera here. The camera is a full struct. It has its own location. It has a width and a height. And when it draws, well, first of all, it queries for the grid that we have. Now, I'm having like here a grid, and we're eventually going to do it as a grid as a struct that's going to store all of the items, all the game entities that are in it. But okay, so we're gonna query all those. Oh, we do this push transform thing. So we do a push transform. We do a new draw param. We do a dest. Okay, point from self location times -1. Okay, so negative location to okay, so we need to do a push transform first, and then a pop transform after we draw each of the items out according to where they think they are, I think. So if we look at that here, that would be a push transform. So that's just graphics. So push transform pushes a homogeneous transform matrix to the top of the transform model matrix set of context. Okay, so this takes into context. We have that. And then the transform itself. So this is where that 2 matrix comes in. And this is what we see here. We have a draw param new, and then dot dest point to from. Okay, so we're gonna use dest in here. Okay, so this is an option, so that's why it's a sum. And then inside of here, we're going to do this draw param new. Draw param new. We're going to have a destination to sort of like set what that destination should be. The destination is a 0.2, so we're going to do dot dest. This type of 0.2 is a mint 0.2. So we're going to go back to this. We're going to do a dest is a mint 0.2 with F32. Do dest, which is going to be a 0.2. We're going to start with 0.0. Y is 0.0. Self dot dest. And then 2 matrix at the end of this. So that's the end of this draw param. Okay, so draw param, new dest. There's that. Dot 2 matrix. And you don't return anything. Okay, so then we're going to draw the grid, and then I want to pop transform and the context. And there we go. So we wrap this. Now, when we do this draw the grid, I don't know if I want to like move it at all. I just want to like keep it exactly where it is. And we're not going to debug this. And okay, so for this one, we're going to do dest.x plus 1.0. So we're going to see if this moves us around. Let's see how it works. So that didn't move the way I sort of expected it would. I don't see the grid moving at all. And I'm increasing it by 1 pixel. So that should be moving. Now, we have some of this extra math here. We have to sort of figure out. We have our self-dot location times -1. Now, self-dot location is a vector too. So it is an x and y that we're getting. We're making this -1. So what if I subtract instead? So do minus equals, and so we go backwards with this. That still doesn't do anything for us. Okay, so push transform. Oh, apply transformations. I'm missing that. We need to apply transformations. And that's after interesting. Okay, so we're doing this right after you. Okay, so apply graphics, apply transformations. So that'd be like the equivalent here. So apply transformations, context, question mark. Look at this. The grid is now moving. The grid isn't moving at all. We have a camera that's moving with this. It basically says, while this transformation is on the stack, translate all the objects to be relative to the camera position. Ah, right. I like this type of math is the one that sort of like breaks my brain. I have to like constantly write it out or like see it graphically so I don't break my brain. I'm just still not I'm just still not used to this. Okay. This is looking pretty cool. Now, if I want to follow the ball, then the pop should happen after rendering everything. Right. Okay. So let's now put these inside of here. So we're going to draw the grid. We're going to draw the ball. I don't know if apply transformations should happen before everything else or after. But if I just do this on its own, and then I want my destination x to remain 0. So I want my dest.x basically this is our camera, right? Our self.destination. We want to follow the ball with this, which means we need to know what's happening with the ball. Let's actually just sort of like manually do this right now. So we're going to do y plus equals 10.0, whatever this looks like. Pop transformation. All right, so you need to return okay like that, and then you are going to return question mark like that. Okay, what does this look like? That was the wrong direction to go. We want minus equals. And so we see this going down now. And then the ball sort of falls with it. So if I want to follow the ball, then I want to set the destination X and the destination Y to where the ball is, which means that I need to extract the ball from the entities here. Now we only have one entity right now, so it should be pretty simple. We could, it's not the best here, but we can just say self.dest.x equals self.entities, the first one dot do I have access to that? I'm gonna make this public. Oh, but I can't because wait, can I? No, I can't. Okay, so dot location dot x. The other thing is that this is a rectangle, but oh no, it's just a point. Okay. Where's my update? There you are. Self destination y equals, and we have to multiply this by -1, I believe. Otherwise, it won't follow it properly. It has to be the opposite of it. So we want set u equal to self dot, and really, I don't have to multiply it by -1. I can just set a negative in front of this. So negative, whatever that is. Negative self dot entities position 0 dot location dot y. So if I do this, we should follow the ball now. And we see that we're actually following the ball in the top left of it. Okay. I would then want to, if I want to like be in the center of the ball, my destination X has to be in the center. So knowing the width of the camera, well, basically this is going to be the width of the camera. We know that's going to be, what, 1280? So half of 1280 is 640. So this is going to be plus 640.0. And you are going to be plus 720 is, oh, not 310. Let's just do like 400. It's not going to be fully in the center, but it should be closer to the center than it is right now. Okay, and so this allows us to sort of see this here. We're not getting super smooth movement with this, and I think that's, I wonder why exactly is it moving too fast? Is that our problem? Because we're constantly just adding more and more speed to it. She cannot take it. I know. What we can do, super smooth movement. You don't say. Now, probably the easiest way to fix this is to add a terminal velocity to our world. So let's say I go in here to our physics system. We've added our velocity. So we've updated our acceleration. Okay, so before we update our velocity to this, we want to now cap our velocity. So let's just say if self dot velocity is greater than, I don't know, let's just try 10. Then self dot velocity is equal to 10. Else if self dot velocity is less than negative 10, self dot velocity is equal to negative 10. This is a very just basic terminal velocity cap here, so it can't go faster than 10. Now velocity, you're a vector. Okay, so that's a problem. We're doing this as y right now. Okay, so we have a y terminal velocity. Let's see what happens. 10 is probably too... Yeah, okay, so it's not going any faster than this. It's still a little bit jerky. I probably don't want to be updating. I probably want the camera to be following it, as opposed to just constantly setting the camera to be down. Now we've set this to be 10 as the velocity for this. If I were to go back to just saying, hey, you know what? In update, the y is minus equals, so not whatever that is. We're just going to say minus 10.0 minus equals. Oh, the ball will never catch up because it's not going faster than this. I would have to wait for it to... start there. So... Oh man, yeah, this gets interesting. So if I do... Yeah, camera following algorithms is a whole area in itself. I know, I've not really paid much attention to it. If I do 5... the ball should catch up and surpass the camera. So we're going to start ahead, and then a ball goes down. Okay, and that's a lot smoother as the ball follows. But yes, that's going to be interesting. Now, in reality, I don't actually want to have the grid showing, which is going to help things be a little bit more smooth, I think, especially if we build this in release mode. But we might need to actually build a full camera system. Okay, so if we need a camera system, we also need a grid system in order to query the grid for what's on the screen. And then just draw those things that the camera can see. And then the camera moves around, does these pops and push to the transform matrix, and then that makes it much happier. So I don't know how much of this I want to do right this second. I'm gonna, before I forget, we're gonna save what we have. This is we have the ball following, so we're displaying a grid and move across and follow the ball as it falls. When playing games, I've noticed that the camera isn't actually just stuck to the ball. It's a very smooth movement. So if the player is moving and then stops, the camera usually continues and then sort of bounces back a little bit. And I think that's to solve some of that sort of the jerkiness a little bit. Is the camera is smooth, everything else is just sort of on its own, and we don't want to like. I mean, most likely we don't want to like set the camera a little bit too rigid, as it were. But as Usby said, cameras are a whole science in of themselves, like figuring out what exactly we want it to be and how we want it to look. So I'm going to have to figure out what the next thing I want to do is. It might end up being creating the grid idea, but I might also want to create something for the ball to bounce on. And then sort of like test that out. I'm not exactly sure. Maybe the grid would be good. I'm planning on doing a spatial, what's it called? Spatial positioning grid. So probably not a quad tree. I'm not necessarily sure we're gonna have that many objects in it, but maybe we'll just have like a grid for the standard world units. Anything that the center of it is inside of there is going to go inside of its grid. And then, so if I let's reset you back to normal. So what is our update? Destination -5. I want to set you back to equals minus self dot entities 0 location dot y plus, I don't know, 350. If you do a quad tree, then it's more scalable. Supposedly, a quad tree could make it so that there's only 4 or 2 items that are being updated together at any one time, and I'm not creating grid points that are that just are empty, that don't have any entities inside of it. So if all the entities like cluster together really close, then a quad tree is probably going to be like much better for us. If everything's sort of spread out, then it won't really matter that much. That's my understanding of it. I've never done a quad tree before, so that might be interesting. But okay, so if I do this and I want to come back to our mod and I want to set our gravity to like really, really slow. And I want to watch this. So in a grid-based movement, let's actually make this slower. I want to say like, okay, this ball is in this grid item. Now it's right here. Now it moves down here. And so that it's going to be inside of each of these grid things. And then that way, if there's anything else in there, I can say, okay, check collision detection for anything nearby you. Otherwise, you don't have to check collision against it. If there's another object over here, they don't have to check each other for collision detection. Which will make it a lot smoother when it comes to having lots of entities on the screen, especially if they have to do collision detection with each other. The other thing is like when it reaches the bottom of this this world, I would want it to collide against maybe a floor. And when that happened, like I don't want it to check collision against the floor when it's at the top of the world. That just doesn't make sense. So we're gonna have to figure that out too. Right now, of course, it just falls off the world. What is that dot above my head? Oh, the dot. It's my. It's the drop game that we created. That was one of the first projects we did live on stream. It's a Stacking just showed it, and Chantilly. It's a drop game. You can do bang drop and try to drop a nice little square on the roving raft. I think it's like a raft on water is the idea. When this gets too fast, I notice that it's a little bit jittery. All right. I wonder if that's also like floating point number problems, because like we're having to convert back and forth. We might be losing some. We might be losing some something there. I'm gonna have to think about what the next thing we're gonna do is. That being said, it is 8:31, which means that it is time for us to switch over to ending. So I'm gonna see who is streaming right now. Who do I have? Let's see. Who I see is streaming. Let's see. Nobody that we haven't rated in a long time. And everybody else that I'm following is just playing games.